Okay, I'm going to do a few examples that should finish off what you need to know for Chapter 15. So you will need to look in your book on page 363. I've copied the table because we're going to refer to it quite a bit, and I wanted to have it here in front of me. However, I'm not going to copy down all the different problems. So this is dealing with a Gallup survey who asked 1,005 U.S. adults who they think better fits their idea of what a first lady should be. And so their choices were Hillary Clinton or Laura Bush, and some people chose either equal, neither, or no opinion. So those categories were lumped together. So our responses had to fall, of the 1,005, had all of them fall into one of these three categories. So if we look at Part A says, if we select a person at random for out of the 1,005, what is the probability that the person thought Laura Bush best fits their first lady ideal? So the probability they chose Laura Bush, we would look for 508. So let's write some notation. Probability they chose Laura Bush would be 518 out of 1,005. And if I change this to a decimal and I'm rounding to 3 places, you can just divide and you'll see you get 0.515. Okay, Part B. What is the probability that the person is younger than 50 years old? So the probability younger than 50 we get. Now, find the people that are younger than 50. Now, we don't care. We're not looking here. We're looking in the margins. So 217 plus 416 were younger than 50 out of all the people. And so when you, let's see, we get 633 out of 1,005. Dividing to 3 decimal places and rounding, we get 0.630. Part C. What is the probability that the person is younger than 50 and thinks Hillary Clinton best fits their ideal? Now, we're still talking about out of the 1,005 people. So we want younger than 50 and thinks Clinton is the ideal. So younger than 50, we would be looking at, let's write this out. I'm going to put younger than 50 and Clinton. So we get 135 plus 158. Those are the people younger than 50 that also liked Clinton out of 1,005. And when we do that, we get 293 out of 1,005. Rounding to 3 decimal places, I get 0.292. Oops. And now for, okay, let's see what's going on here. All right, pen's getting a little sensitive. It's probably getting tired of working so hard. I'm sure you guys are wishing I'd give it a rest. Okay, Part D, what's the probability the person is younger than 50 or thinks Hillary Clinton best fits their ideal? So we need the probability younger than 50 or thinks Clinton is the ideal. So we need to think about this one now. Now, since it's an or, I'm going to try using a formula. It's going to be the probability younger than 50. It's an or, so it's plus the probability of choosing Clinton minus the probability of both. Okay, so I'm using the addition formula. You can go back and look at that if you need to. So the probability, here we go again. So the probability of being younger than 50, I think we already did that, didn't we? So the probability younger than 50, we had 0.630. I'm going to leave it 633 out of 1,005. So this is not rounded. And the probability of choosing Clinton, I don't think we had done that one, but let's look up here. It's 437 out of 1005. And the probability of both, we already figured out, was 293 out of 1005. Okay? If you were to add those and then subtract very conveniently, have a common denominator, you can verify that you get 0.773. All right, so you can double check that. All right, let's take a look at problem 13. It's going to deal with the same setup, so that's not changed, but just a little bit different questions. Part A, and you might want to look in your textbook, says if we select a respondent at random, what's the probability we choose a person between 18 and 29 who picked Clinton? So age between 18 and 29 who picked Clinton is going to be 135 out of 1005. And let's see, we get 0.134. All right, part B. Among 18 to 29-year-olds, what's the probability that a person responded Clinton? Now, notice this is a conditional distribution. So this is saying, given that they were an 18 to 29-year-old, so I'm going to write it this way. What's the probability that they chose Clinton given they were an 18 to 29-year-old? So this becomes my new sample space. So I'm looking at just the 18 to 29-year-olds. There were 217 of them, and 135 of them chose Clinton. Whoops, we're having some problems here too on the calculator. Sorry about that. And we get 0.622. Okay, let's look at part C. What's the probability that a person who chose Clinton was between 18 and 29? Now notice the wording of this. Now we're given something else. So we want to know the probability they were 18 to 29 given that they chose Clinton. Okay? So given they chose Clinton, what's the probability they were between 18 and 29? So if we look up here, given that they chose Clinton, so out of the 437, what's the probability they were between age 18 to 29? So we have 135 out of 437. And we get 0.309 if I round to 3 decimal places. And part D, if the person responded Bush, what's the probability that they are over 65? So we're saying if they responded Bush. So given that they responded Bush, what's the probability they're over 65? So we're going to take given Bush, 518, 92 were over 65. Maybe I won't simplify that. I'll just leave it. You guys could do that part. And one more, part E. What's the probability that a person over 65 preferred Bush? Now notice the wording on here. This time we're not given anything. What's the probability a person, oh yeah, we are. A person over 5. So given that they are over 65. So sometimes it's really subtle. what's the probability that they chose Bush? So, given they're over 65, there were 167 of them, 92. So 92 out of 167. Okay, we're down to our last example. Problem 27 on page 365 still deals with the idea of the First Lady. So still same setup, different questions. Part A says, are being under 30 and being over 65 disjoint? And then explain. So being under 30, so let's think about where that is, being under 30 and being over 65 disjoint. Yes, they're disjoint. And if you think about why, you cannot be, remember we're selecting one person at random, you can't be both under 30 and over 65. All right? So they are disjoint. Remember, disjoint means no outcomes in common. So it's impossible to be both. You can't overlap under 30 and over 65. Part B, are being under 30 and being over 65 independent? So now we're looking at under 30 and over, that's an and, not a plus, and over 65 independent. Now this is, in class, I left on Friday, kind of, or on whatever day it was, Thursday, kind of talking a little bit about this idea. Remember that to be independent, knowing that one event occurs can't change the probability of the other. For example, remember the probability of A given B has to equal the probability of A, if independent. So think about it. I'm selecting one person at random. I have a probability associated with under 30, and we calculated that. Under 30 was 217 out of 1,005. I have a probability associated with over 65. 167 over 1,005 would be the probability of being over 65. So now I'm saying, when I ask this question about independence, if you're given that the person chosen was over 65, now the probability of them being under 30 drops to 0. It's no longer going to be 217 out of 1,005. So because of that, they are not independent because the probability changed. This does not hold true. So these two events are not independent. And we can even go further than that to say disjoint events, or mutually exclusive events, same thing, are never independent. Okay, again, the reasoning on that was if this, once you know if this occurred, this probability changes, it would drop to 0. So it can't be independent. Part C, are answering Clinton and being over 65 disjoint. So Clinton and over 65, we want to know if it's disjoint. So let's look up here and think about that. Remember, disjoint means do they overlap or not. So choosing Clinton, oh, we got that little thing going on here again. Okay, so choosing Clinton, we had 437, well, let's see, Clinton and what are we looking at? Over 65. So we had 437 people chose Clinton, and of those 437, notice that 65 of them were over 65. So we have an overlap of people who are both over 65 and they chose Clinton. So we would say no, and we could say 65 people are over 65 and chose Clinton. And one last part, part D, are answering Clinton and being over 65 independent? So let's check this. Let's see if the probability of choosing Clinton, given they're over 65, let's see if that's equal to the probability that they chose Clinton. Because this is one of the ways we can test it. So we want to know, is this true? If it's true, they're independent. If it's not true, they're not. So let's look at the probability given they're over 65 that they chose Clinton. So given they're over 65, out of the 167 people, 65 chose Clinton. So 65 out of 167. That's this side. And we want to know, is that equal to the probability of choosing Clinton? 437 out of 1,005. Grab our calculator. 65 out of 167 is 0.389. 437 out of 1005, 0.435, not equal, therefore not independent. That means age category must be somewhat related to whether or not they chose Clinton or Laura Bush as their ideal. So age must make a difference. That's what we're looking at there. And that is it.